Hello, my name is John, and this is my Tech Demo 1 for Multivariable Calculus. And the first thing that we are going to go ahead and do to graph this stuff is I'm going to go ahead, I'm going to change the all the maxes and mins to 8 just to make it easier to visualize the things that we'll be graphing today. I'm going to go ahead and remove this, and here are the new axes. These not necessary, but it looks better when you graph it like this. And so the first thing that we were told to graph was the line vector. And so in the original line equation, it was 111 t at plus 10 0 0. So when you write that as one single vector, it becomes 10 plus t, and then t for y, and just regular t for x and y. Just the line vector right here. See, it's going down the z and y axis, straight down with diagonal line, excuse me. So now the second shape that we're going to be the first shape that we're going to be graphing is a plane. So we're just going to use the implicit surface function, and we were given the formula for that, so we can just go ahead and plug it in. The formula for that plane was 2x plus y minus 2z equals 2. When you graph that, that's what shows up right there. Got a nice plane. And now this plane is going to be intersecting with a cylinder. So we're going to use another implicit surface function for that. And we were also given the equation of the cylinder, and that was x squared plus y squared equals 3. So there's our cylinder right there. And you can see the intersection. See if I can get a better angle on this. There we go. So you can see the intersection as it goes along, and what we are looking for, let's start spinning, and what we're looking for is what exactly the curve of this intersection is going to be. So you can see it's going to be an ellipse, because if you look at it head on, you know, the inside of the cylinder is a circle, but it's slanted because of the intersection with the plane. So we are looking for an ellipse equation right here. And so the way you find that equation, or those coordinates, the x, y, and z coordinates, is you have the ellipse and cylinder equations. You can simplify the cylinder equation down to x plus y equals square root of 3. That's our radius. And then you plug that radius into the x and y components. So x is always cosine of t, y is always sine of t, and you just multiply those by our radius. And you can plug all of that into the ellipse equation to solve for z. And so as you can see right here, what we did was we moved z to the other side of the equal sign, moved 2 to the other side of the equal sign. We have 2z equals 2 times square root of 3 cosine t plus square root of 3 sine t minus 2. So then we just divide everything by 2. We get t equals square root of 3 cosine t plus square root of 3 over 2 sine t minus 1. And now we can go ahead and plug our x, y, and z values into the space curve function, because that's where you can put in each of those components separately. So that is going to be square root of 3 times cosine t for x, and same for the y component. So square root of 3 times sine x, and now the z component is going to be the longest one, so that is going to be square root of 3 times cosine t plus square root of 3, square root 3 over 2 times sine t minus 1. Go square root, square root, square root. And we got to change these bounds to 0 and 2 pi, because this is a circular object. Let's see. There, and there you go. There's our ellipse right there. As you can see, it lines up perfectly around the cylinder, and also lines up and is right on top of the curve. The plane. And so, just to visualize and show it as its own thing, you take away the plane first. You can see it wraps around the cylinder like a rubber band. And you take away cylinder, and now you have your ellipse alone in space by itself. And this is what the curve of the intersection of those two objects in space is. So now we can go ahead and add these components back in. Just show the full thing. Oh, too far out. But yep, there you have it. That's how you find the curve of the intersection of the plane and cylinder. Thanks, and have a great rest of your day.